Right, we are continuing in set chapter 6, a bunch of applications to the trig functions. In this case, we were talking about polar coordinates. Your polar coordinates have interesting functions to start with. Um, we are going to look specifically at plotting points, find multiple sets of polar points, coterminal angles type things. So this ought to be familiar to you, although for some reason it's a concept that's tough to get across. Want to convert points um, from polar to rectangular and rectangular to polar. And then tomorrow we'll get into equations, converting equations. So to start with, we're looking at these things called polar coordinates, and you'll notice that the grid is a little bit different than what it has been in the past. You still got the x and y coordinate. You still got your trig, um, your unit circle going around, but you've also got the concentric circles. And that's what makes the polar graphs, polar coordinates, unique, are the concentric circles. I'd like to tell you that graphing these on Desmos would be easy. Unfortunately, Desmos hasn't quite figured out how to graph these um, in a format that's easy. What we have for you, if you want to look at it, you've got a little bit of an algorithm to go ahead and be able to plot these. Once you have the algorithm down, then it makes it easy to plot. Again, I'm not real sure this is helpful, but you can see how the uh, polar graph looks on Desmos. All right, so let's jump into this. Um, Starting out with the sign of R in the point's location in polar coordinates. The point P is represented by r theta. So you got your radius and your angle, where uh, absolute value of r is the units from the pole being the origin, and r is greater than 0. The point lies on the terminal side of theta. If r is less than 0, the point lies on the ray opposite the terminal side. In other words, we're going to the negative. You got a negative radius. Positive radius, negative radius. Um, if r is equal to 0, the point lies on the pole. That's again right there. It has no radius, has no length, so it's just a point, regardless of the value of theta. And again, you're looking at another polar graph in radians. You can do polar graphs in degrees. This one got a little excited and has every 10 degrees on here. Doesn't have to be that um, detailed. The one of the things we'll probably be doing is just simply using a polar graph, a generic polar graph with concentric circles. You can print these off the internet. There's blanks on the internet if you want them, but you could very easily draw one of these. So don't get too hung up on that. All right, plot the points in the with the following coordinates. So again, we need a polar graph, and we're going to plot these points. So A says we're going to go out 3 circles, right? 1, 2, 3. So we're here, but it wants us to rotate 315 degrees. Well, 315 degrees puts me all the way to this point here. All right, so I'm here. Let's go ahead and plot that. That's A. B says we're going to plot -2. Remember, -2 goes this direction, -1, -2, and it's rotating pi units. Well, remember, the positive rotation is counterclockwise. Pi units is going to put that here. So again, that's B. C is -1, going negative again, this direction, rotating -pi/2. Remember, the negative rotation goes this way. -pi/2 puts you right here. And again, C. All right, you may have to go back and look at those again and get them figured out. Multiple representations of points mean that you're going to have some r theta where you've got your radius, and then you've got theta plus 2n pi. In other words, multiples of 2 pi. In other words, if you have a point here going all the way around, ends up here again, 2n pi. Or you could rotate in the negative direction, and you would be adding pi or multiples of 2n pi once you've added pi to that. So it's an odd number of pi's. All right, let's play with this, see if we can make some sense out of it. This is too soon. Okay, so we want to find another representation of 5 comma pi/4 in which r is a positive and theta is between 2 pi and 4 pi. All right, well, this is going to be interesting because we go out 1, 2, 3, 4, 5, right? And we are rotating pi/4, which puts me right here. This is my A value, correct? But we want that theta now to be between 2 pi and 4 pi, which means I've got to add pi/4 plus 2 pi, or pi/4 plus 8 pi/4, which is going to give me 9 pi/4. So this location is not only 5 comma pi/4, but it is also located in the same location as 5 comma 9 pi/4. They want us to locate r is now negative and between 0 and 2 pi. So same point here, same point, but a -5 starts here, and we've got to work positive. So our positive rotation goes this way, right? Okay, isn't that going to be 5 pi/4? So this is now also -5 comma 5 pi/4 units. Okay, keep in mind, starting at the negative, rotating positive puts us there. All right, then next, r is positive in a negative angle. Okay, well, if r is 5, and now we rotate this direction, right? How many degrees or how many radians to get to here? Well, that's going to be +5 comma negative. That's pi/4. That's going to be 7 pi/4, one less than 2 pi, right? All right, so you have all those solutions. This was C, this was B, this was A. All right, these are tools that you're going to have to memorize. So write them down and memorize them. X is equal to r cosine theta. Y is equal to r sine theta. Our Pythagorean theorem is familiar to us, right? X squared plus y squared equals r squared. That never changes. And you guys, this one's kind of an interesting one. Tangent of theta equals y over x, you know. But consider that this is rise over run, right? So this is, if you will, a slope. So tangent of theta equals y over x. Those are 4 tools you have to know and remember. Write them down so you have them in front of you when you do homework and take a test. All right. Find the rectangular coordinates of the points with the following. Consider the fact that we are converting to rectangular. That means we need to find x and y. So we have formulas that say x is equal to r cosine theta. Y is equal to r sine theta. And now plug those in and solve it. I'm going to stop the video and let you guys do that. Okay, again, stop the video and take a look at this. See if you can follow what we did. All we're doing is plugging numbers in. You know that 3 rotated pi units puts that, here's 3 units rotating all the way over here, puts that here. That's A, right? Or negative 3, 0 puts that in the same location. All right, stop the video and try B. Again, negative 10 out here, rotated pi over 6 comes down to here, or the coordinate plane, negative 5, negative 5 root 3. I said that backwards. Negative 5 root 3, negative 5 puts you in the same location. All right, and find the polar coordinates of these whose rectangular coordinates are given. We've given the rectangular coordinates. We need to find r and we need to find theta. So again, going back to those tools, you know that r is equal to the square root of x squared plus y squared. Theta is equal to the inverse tangent of y over x. Stop the video and give that a shot. All right, I'm going to pick up where I left off here. We got the radius of 2, which is just plugging that into the formula. Inverse tangent, we can plug this into a calculator. We can do this in our head. This was negative root 3 over 2 divided by 1/2, which puts us at a negative pi over 3, right? Do we need that to be as a positive? No, not necessarily. Unless they ask specifically for that. So our 2 comma negative pi over 3 is your polar coordinate. All right, example 5 says find the polar coordinates given the rectangular coordinates. I'm going to stop the video and let you do that. Okay, so you've got a radius of 4. Always plot the point, you guys. You know what? There's no real work to be done for finding the angle. If you know where it's located, it's got to be 3 pi over 2 or negative pi over 2. My ordered pair here is going to be 4 comma 3 pi over 2 or 4 comma negative pi over 2. So just for fun, I added 2 more. Those are all the same location depending on whether it's a positive or negative radius. All right, good luck.